Hello and welcome to the first video in this series making simple Flappy Robin using Cocos2dJS, so the JavaScript API. This video has come about, or this series, because I've had a lot of requests after doing the two versions of Cocos2dX and C++ versions 2 and 3. There have been a lot of requests to do the JavaScript version. But there's going to be a but with this. There are two versions of Cocos2dJS. One is the full version, it's at the moment 3.5, I've got 3.3, and there's the Lite version. And the difference is if I just navigate to the folder with Cocos2d here, where I've downloaded version 3.3, here we have a very similar structure to what we have with the Cocos2dX version. Frameworks, templates, samples, tools, etc. all ready to make and create your projects much in the same way that you do with Cocos2dX. The difference is you'll be writing the code in JavaScript, and then behind the JavaScript there are various bindings to connect everything to the native languages and build your application for Android or whatever whatever platform you want to run the application on. Now, I've got at least 3 videos on the channel for Cocos2dX of setting up Cocos2dX with Eclipse and Android. I don't want to do a 4th one because it's more or less exactly the same process. But what will be interesting for this series is actually writing the JavaScript to get the application to work. And for that we'll be using the Lite version, because that gives you one file with all of the JavaScript API inside. However, I would recommend that you download the full version anyway, because there's this folder samples inside, and this is what I used because I wasn't familiar until about 2 days ago with the API, or very familiar. And inside here, as usual, much as C++ version, you get all of your various tests for testing out the API. So if you want to know how actions work, just jump into the JavaScript for the actions test and it'll explain. You'll have some very simple code there showing how it works. Touches test, the same thing. In fact, this ball and paddle is an excellent introduction to exactly how most of the things we'll need works. Sprites, extending sprites, touches, updating 60 frames a second, etc. is all inside there. And I find the touches test is always the best example to use to understand how to get going. So it's worth downloading the full version just to get the samples, or the code for the samples. But in our case, we'll need the Lite version, as I said. So you just click on download Lite version. I'm going to take version 3.3, or it's the version that I've used. So I recommend you take that one. I'm not sure what the differences are between that and 3.5. I don't want anything to go wrong for you. Just select Lite version. I selected uncompressed and download. I'm not really bothered about the size. And when you've downloaded it, what you'll get is you'll get a zip package called Cocos2dJS version 3.3 Lite, and inside that zip package you can see here I've got the zip. I extracted it just for an example here. We get all of these files. Now before we go on to actually, if you running this, if you double click on hello world.html, in fact I can do that now, it does actually load and work, but it doesn't actually quite load correctly and at the correct size, which we'll see why shortly. And in fact, if you started trying to move sprites and things on this, nothing would actually work at all. And the reason for that is you actually need to have a web server serving up the pages here for the API to work properly. So if you don't have a web server set up on your computer, you need to get one set up. If you're on Linux or Mac, I think Apache is already, if I remember from the Mac correctly, Apache is already installed. You just go into Google and you just need to Google starting web server Mac or Linux to get it going. In terms of Windows, you could either download and install Apache and get it going, or Windows comes with IIS. And in fact, if you put into Google IIS web server, you'll find, well, here's already a video in the search results to tell you how to set up your web server with IIS. You just simply have to, I'm not going to show in the video how to do it, but you just go adding Windows features, tick a box, it's there. And the only thing I would recommend you do is you tick the box when you set the web server up to allow file browsing, such that when you type localhost, you get the list of directories wherever your web server is pointing. You can tell your web server to have a root directory anywhere on your computer. And in my case, inside Cocos2d directory here on the C drive, I've got the JavaScript website here, and that's actually the root That's where the web config is here, the root of my website, and there these 3 directories you can see represented on the page here. What we're aiming to develop, and what I've already done, is if I go to Robin full and actually just start robin.html, you can see here that we've got the game up and running, a simpler version as possible to keep this series nice and short, because rather than the bells and whistles that were there a bit more in the previous series, this is purely about how do we write the JavaScript to get this working, and this is all done inside JavaScript. The other thing we've got is I've decided in this version to maintain the aspect ratio at all times rather than fill the browser window. You can actually do both. What it does is, you'll remember if you followed the Cocos2dX versions of the series, there was a lot of setup done to make sure we scale for all kinds of aspect ratios. In this, there's a way with the JavaScript API of just simply always scaling everything correctly to your selected aspect ratio, which is what we're doing, which is why you see it working like this. So this is the full working version that we'll be aiming to complete in this series. If I go back into localhost, however, I'm going to be more interested in the actual tutorial of what we've got going now. So inside Robin tutorial here, I've got the zip file from Cocos2dJS 3.3 Lite, and I've also added in a folder called images with some images for the game inside, a folder called JS for the JavaScript, and a folder called sounds for the sounds. And all I'm going to do now is simply extract into this directory the API that we downloaded, the Lite version, which will extract these files here. I'm just going to delete the zip file so it doesn't distract me. And what we find is we've got our hello world here, our JavaScript API here, and actually everything we need. This hello world PNG, you'll notice probably already from some testing, I'd already copied and put that into images, but you don't need to do that. But let's actually refresh Robin tutorial here, and let's just have a direct look at this hello world HTML to see what we've got. And what we can see we've got a background image here, and we've got the hello world text printed on the front of the background image. So what we've actually got here is this window here is what's known inside Cocos2d as a scene. So our window is a scene, much like you might have a scene in a movie, and it's a bit like, say, if you're working in GIMP with an image program or Photoshop, it's your image. And you can add onto this image layers. So you add a layer onto the scene, and on that layer you can then add your sprites and various things like that. So here we've got a layer on the scene, and on that layer has been added this background picture with the grey borders here, and also a label with hello world text, both onto the same layer, and this layer has then been added onto the scene. And you can add multiple layers onto a scene. So if you've got a complicated game, you might want a background layer where you've just got some things that move around but have no interaction with the user. And then you might have a layer for enemies where the user doesn't actually interact with them, but they come on the screen and do various things. And you might have a layer then for the player which detects the touches and things like this. But the point is, you always have a scene, and that scene then draws the various layers, and on the layers are the various images. We'll see that in code. So that's what we have very simply here. We have a scene and a layer all inside one. And this image here, as we'll see in a bit, is actually scaled down a bit, so we've got a black border. And it's important, as I said, that you've got this being served up by a web server, otherwise things are not going to work. So without further ado then, what we can do is go back into our folder and actually start having a look at some of the files and the code that has come with things. So I'm just going to open up hello-world.html inside Notepad++ here, and let's take a look at what we've got. And the first thing that we've got is we've got the inclusion here of the JavaScript. And the first thing I'm going to do is I'm actually going to do a JS and a / and save that file. And I'm going to drop the JavaScript file into JS here to clean things up. The next thing I'm going to do is I'm going to delete this hello world. Well, I'm going to copy this hello world PNG into images. Now there's already one there, so I'm going to replace it so that we've got the hello world PNG into images to clean things up a little bit more. Which means when I go back into the HTML here, you'll see that we load up this hello world PNG here. Well, now I'm just going to type images and /. We'll be changing all of this into not hard coding the strings in this way later on, but also here I'm going to replace the hello world PNG like so, and I'm just going to refresh the app to make sure everything's still okay, and it is. But we want the images JavaScript in here, and we want the images in here to keep everything nice and neat. I've also, I can't remember if I mentioned sounds, but I've also made sounds as well, which will be available for download. Good, so let's go back into Hello World and have a look at what we've got then. And we've got a script running inside the HTML, inside a script tag here, JavaScript, which is you familiar, hopefully, with JavaScript. When the window loads, it calls this onLoad function. And what we have then is we have an onStart function for our Cocos game here. And the game is told to run here with the game canvas here, which is canvas set to a width of 800 and a height of 450. And when the game actually starts, this onStart function is called here. A preload is called to preload resources if we need to, and things like that. And then at the inside this preload as well, we say that we want to start running our scene, which I've explained is all of the holds then our layers. We run a new myScene object, which is created here, and inside the onEnter here, we actually, without using a layer, we actually directly add onto the scene a sprite with our image and a label. Now I've gone through that quickly because I'm going to explain that in a little bit more detail, but I want to clean up what's been done here, because first of all, we're not going to have our JavaScript inside the HTML, and second of all, everything's been done a little bit convoluted. I'd like to split everything out so it's very clear into a scene, to add a layer onto our scene, and then tell our director to run that scene and have everything separated out nicely rather than wrapped up inside itself like this. So to do that then, the first thing we're going to do is create a new file. And I'm just going to type some text so it lets me save it. And I'm going to save this inside JS, and I'm going to call it game.js first of all. And the first thing I want to do is I'm going to take and cut out this code here and just drop that inside game.js and save it. And then I'm going to quickly copy this part here to make things short and sweet for the script. And we're just going to change this link here to game.js so that we reference our game script. Now, I should be able to refresh the app and everything should work as it did before, and it does. So we've got all our links set up correctly and everything like that, so we don't have any kind of silly disaster. The next thing I want to do now is start cleaning up all of this here. So the first thing we're going to do is we're going to create our game layer. So this is the layer that we add then to our scene, which will contain all of our images. So I'm going to call this game layer, and this is going to be equal to cc dot and layer, and then extend. So we're going to extend our cc layer, and then we want some curly brackets and a close, and we want some curly braces. Oops. And inside here, we want to set up our layer. The first thing we're going to set up is the constructor, which exists in the layer itself, which is a function. And then this function here, inside here, first thing we'll do is we're going to call the super constructor. So this and super, and I've made an error there, I need to put a dot in. And then what we're going to call is we're going to call init as well, so initialization as well, which we'll be defining shortly. So the constructor is now defined then, and that's also present in the layer as well, which is why we've got the super call here. Next thing we want to do is the initialization function, which is also present in the layer as well. And incidentally, for me, JavaScript, and there's a lot of debate about this, isn't really an object-oriented programming language. I don't like doing things like this. Most of the program we'll be doing outside the layer will be more functional, but for now we'll set things up, I think, in the way they intend like this. Certainly they do it like this in the examples, so we'll keep it going like this. So inside the initialization, we want to set up call super first, and now we can get into the interesting stuff. So the first thing we want to do, we want to be able to position our images in the middle of the screen correctly. To do this, we need to know the size of the screen, and we can get this by asking the director. And you can see it's already been done down here, where inside the onload there was the example code to get the size. So we're just going to cut this out now and drop this in here to get the size of our window. Now we've got the size of our window, we want to create or put an image on the screen. The way you do that is by creating something called a sprite, which we've got here. So I'm just going to cut this code and paste it inside here and explain what it's doing. So we're creating a new sprite object from this image here. We're setting the position of the sprite to size, the width divided by 2 and the height divided by 2. A sprite has what are known as anchor points. So if this is a sprite here, this whole black border, let's say, is a sprite, it's anchored by default at what's called 0.5 by 0.5, which means the position you position it at. If I say I want this sprite to be positioned at half of the width and half of the height, the program has to know exactly which bit of the sprite needs to be positioned at that point that I've specified, because it's obviously bigger than 1 pixel. So what we do is we specify an anchor point, and by default it's half, which means the anchor point is halfway along the width and halfway along the height, i.e. the center of the sprite, which means the sprite's center will be positioned over the position that you set. Or in other words, we're setting the position at the center of the screen here, half the width, half the height, so the center of the sprite will be positioned on the center of the screen. In other words, we'll put the sprite in the middle of the screen. The anchor is 0.5 by 0.5 by default, so we don't need to do anything else. They've also set the scale in this at 0.8. Okay, we can change that later and have a look at the effect. And the last thing that's been done is this, so the layer, is then adding the sprite to it, which means, as a child, which means when the layer is drawn, it will draw this sprite. The number here is what's known as a z-index. If I add another sprite on now, and I add it as a z-index of -1, it will be drawn behind this sprite. In other words, we won't see it. If I add it as a z-index of 1, it will be drawn in front and we'll see it. If I add it as z-index of 0, but put the code below here, it'll still be shown, because if z-indexes are the same, then they're shown in the order that they're drawn, in reverse order that they're added. So last thing to be added will be shown on top. And we can see this then with the label actually. So what we'll do is we'll take this label code here and just cut this out and just paste this inside here as well. Everything is lining up very nicely. So for the label here, I'll just tab this backwards a little bit and try and make it neat. We've declared something called a true type font label. This actually inherits from Sprite, I think, eventually. Set its text to Hello World, its font to Arial, its size to 40. We set its position also to the middle of the screen. Its anchor point is the same by default, a half and a half. And it's added as a child to the layer with a z-index of 1. And we'll have a little, so it means it'll appear on top of this background image here. And we'll have a little look later at the effects of z-index. So that's our layer setup. We've just got one more thing to do to prepare for later. There's also an onEnter function, which was actually being called down here anyway inside the window load. And onEnter function also, for now, we're not actually going to do anything inside the onEnter function. It's just simply going to call this and super again. We'll be dealing with that later on in development of the application. So we've got our layer set up now. So we've got a layer object defined that we can use then to define our layer, which will draw our various objects on here. The next thing we want is we want a scene to add that layer to. And the way we're going to do this is a tiny little shortcut. We're going to declare a scene object or function, which when we call this function, it gets us a scene with our layer added. So we'll create a new scene, and we create this by saying new and cc.scene. And now what we're going to do is create an instance of our game layer. So we'll say new and game layer, which when it's initialized, when we create it then in the constructor, calls init and then adds the label and the sprite to it. And now what we want to do is we want to add our layer as a child to our scene. And now what we can do is we can return our scene in response to this GameLayer.scene function call. So what happens is then when we call GameLayer.scene, this creates a scene, which is the whole window. It creates an instance of GameLayer, which then constructor is called, init is called, and it adds our sprite and our label to the layer. This layer is then added to our scene, so it'll be drawn, and then we return the scene. So now we can clean up the code even more down inside the window.onLoad function here. I can remove all of this scene stuff out of here, and I'll just move this line up one as well. And now what we can do is, instead of saying run scene new my scene, what we actually need to do is we can now just say run scene and GameLayer dot scene, like so. And this will then call this GameLayer scene function, which returns then our scene with our GameLayer added. Hopefully that's clear, and certainly more clear than the code originally was. Okay, so now we've got all of that set up in this way. What should happen, fingers crossed, is things still should work exactly as they did before. So I'm just going to click refresh, and you can see it does indeed work as it did before. Now let's have a quick look at Z layers. If I change this Z indexes to 0, so it has the same as the Hello World image, and refresh the app, we will still see the Hello World label because it's been drawn after the background image. If, however, I cut the code away for the label and put it here, it still has the same Z index, but now it'll disappear because the image has been added after the label was added. If I give it a Z index of 1, even though I'm adding it before, it'll be drawn on top of the background image here, and we'll see the label again, like so. So that gives you an idea how Z indexes work. And just looking at the scaling now, if we now change this scale instead to 1.0, so to the original size of the image, you can see now that the image is fully filling the canvas. Whoops, just back to the code. And if I set it back down to say 0.5, you can imagine that we're just going to get a very big black border and a very small image behind. So you can see the effect of why the scale was being used there. Okay then, so that's really it for this video now. It's a little bit longer than I wanted, which is often the case, but hopefully you've got a good idea of why we have a scene, why we have a layer. We've separated things out a bit better to understand exactly how the game is working. And in the next video, what we'll do is we'll change this background and the canvas size as well to have the aspect ratio we want for the robbing game, and we'll also set it up so that it's, as I showed you at the beginning of the video in the finished app, it actually scales and fits itself with the correct aspect ratio inside the browser. And this is actually just a line of code because the API does it for you. But for this video, that's it. Thanks very much for watching, and see you in the next one.